This session is the introduction to the command line interface. My name is Al Tanner. I am a research software engineer with the University of Bristol. I'm also working with the Jean Golding Institute, and I'm also a member of the Advanced Computing Research Centre at the University of Bristol. This session is aimed at beginners. But if you're not a beginner and maybe you have some more experience, I hope that you'll learn some things as well. Before I start, I also just want to mention my own experience of the command line. And although I've been using computers all my life, it's only really in my master's and at the start of my PhD that I started to use computers in a more technical manner and leading to being a research software engineer now. But I remember being dumped with all of these commands that I had no idea what they did, and I just cut and pasted them without really understanding. And I don't think that's a very good way of learning what you're doing. So I really hope that this kind of session can help people out and give them a better insight into what they're doing with the command line. So the point is here is the command line has this reputation of being something for geeks only, something which is difficult to understand, which is exclusive to a particular type of person, and that's really not true. It's something that the base that you by the end of today you'll know 90% of the things that most people use on the command line. Yes, you can get much more technical, but really it's not something to be, I hope, to be intimidated by. So I really want to dispel any worries you have about using it, or if you feel that you're not the kind of person. I think that if you want to, if you come to a session like this, and if you want to learn new skills for whatever reason, then then you're going to be able to use it. So I really want to dispel any fears you have. There are plenty new words and vocabulary around computing, and I really want to make those clear because I think it can slow people down and confuse people. It certainly confused me when I was starting. And then, as I mentioned, we'll move on to some actual experience, actually do something. In a moment, we're going to start with some history, but first, so I just wanted to ask everybody who's here, why do you want to learn the command line? Are there particular things you want to learn? Or so if you can post in the chat what you're hoping to get from learning how to use the command line. I'll be really interested to hear some views. I've got my own answers, but I'll give those in a second. So Alexa mentions seeing other people use it, and for Git, Anna says bioinformatics. That's where I started too, so I can mention that. Tools and actions, knowing what other people use it for, smart. Sapna wants better understanding. And we've got another user of Git Bash. And expanding on RStudio. Data acquisition, want more control. Great, so these are all really good reasons. And I'm going to just go to the next slide. Lots of words on this slide, but the thing for me is being able to be completely unambiguous. And for research purposes, it's really useful to be able to share what you're doing, be consistent, demonstrate documentation, If somebody else wants to do your to see what your work was doing or to expand upon it, then it's much easier to be reproducible. And it allows you to communicate with other researchers. If you read documentation, it allows you to understand what it's saying. So the command line interface is really a kind of, it opens these doors and it helps you. I mean, if you want to go on to learning to program, this is, I think it's pretty much where everybody starts. It's just learning how to use the computer itself and then moving into the logic of programming. So let's start with a bit of history. And I am not an expert on the history of computing at all. It's a really interesting and complex topic. But the main thing that humans have needed to do is to communicate with computers, to really know that what they're getting the computer to do is what they actually asked, and that the computer can return the answer that it came up with, whether that's right or wrong. And of course, in the early days of computing history, you would effectively wire up the computer for every new program. And you can see here's a computer from, I believe it's the 50s. I'm not totally sure, but I think this is a 50s machine. And these women are rewiring it for every new program. And I think I'm not sure what the output would have been, but I think it might have been printed paper. Someone might want to correct me on that. And just as an aside, the history of computing has plenty of women in it, and it's a really fascinating area. If you look at the early days of computing, there were lots of pioneers before the academics and the men all kind of came in and trampled on everything. So it's kind of sad that we're still trying to build back to having more equality in STEM. These pictures on the right are later computers, and you can see that these people are looking at a bit of paper, and this was a way of communicating with computers. You would have punched bits of paper that would represent the program that's going in. And so these you'd have these stacks of paper or ribbons of paper that we saw in this last one. And that was the way of communicating with a computer. There were no screens. There might have been some basic oscilloscopes, but on the whole, it was extremely difficult to understand, and you had to have years and years of training to really understand what was going on. It was very easy to break things. And then as the evolution into the data storage, so starting with magnetic tape. I know that there were other formats like magnetic drums and other formats which would be, starting to store things in a format that we understand today. And I think it's worth mentioning that the history of the words we use in computing, they really endure. You might have come across something called a tape archive or a tar or a tar ball. We still call them tape archives or tar files, and that's because we would use these tapes. These days, it's not often stored on tape, but we still call it that. Here on the right, we've got people, I believe they're working at AT&T, which is one of the pioneering labs in the 1960s. And so we're going to be learning about these devices here. This is a console or a terminal. And just like with the tape archives, these are terms we still use today, although they, instead of being these hardware devices, they are software, they're emulated. So we could see in this last slide here, here's somebody typing commands into the computer, and it would be a machine similar to this. So here is some punched paper. I guess this is slightly earlier because here we've moved on to magnetic tape, but you can see the kind of crossover into from physical to magnetic media. And again, here's another term which lives on today. Terminal can be a TTY. You might see that in your ongoing experience with the command line. And then as we move into the 70s, this is when the enormous revolution of microcomputing started. So with the advent of semiconductors and silicon chips, instead of having these enormous machines which are running off valves and these enormous transistors, we could get smaller and smaller computers. And so here is a terminal. Again, the origin of the word terminal, so terminal mean the final thing. Like if in a train station, in a train network, a terminal station is a station at the very end of the line. It's the same in computing. This is at the end of a series of connections where you actually communicate with the rest of the computers. So here we have screens becoming more common, and here is a familiar readout on the screen. And as we go from the 70s into the 80s, we have the rise of the personal computer, because of course before this, computers were institutional machines. They took up enormous rooms, they took an enormous amount of power, they were incredibly expensive, and the idea that there would ever be a personal computer seemed crazy in the 60s, and yet by the 70s and 80s we did have personal computers that you'd fit on a desktop and you could use. Now I have to point out that this is not me. I've had some confusion from my colleagues. This is just a classic 80s guy, but yeah, it's not me. But it's not my actual one, but this is the first computer that I had. No, it's not actually, James. So I couldn't. I did ask my dad, "Do you have any pictures of me on the BBC?" But not only would it have been difficult to find them, but they would also definitely have not been digital, so it'd be difficult to get them to me. But these kind of machines became affordable, at least for some people, and you could have it in the home. And yes, my first machine had 16K of RAM, so that's about 5 sides of A4 with the entire contents of the RAM, whereas your phone in your pocket has, I don't know, 8 gigs of RAM, which is about, I calculated this earlier, it's about 220 meters high stack of A4 paper would be all of the RAM. So we're all living through this ongoing race of technology and this change in interface. But I think one thing we must keep in mind is that it's only since the 70s and 80s that computers have become consumer products. And so you have one interface, which is all graphical and touch screens, and it's all very easy to use, and it's all very pretty, and you don't have to worry often about how things are working behind the scenes. But behind that, whenever you see somebody use it, if you're not familiar with the command line, it can just seem like the same interface has been used for the past 50 years or more. And that's kind of true, because when we get to the 1970s and 1980s, if we can use a written language rather than the punched paper, that's obviously not a natural thing for a human being to be able to read and write. But writing on a screen is something that humans do fairly naturally. And although the interface and the way that the command line communicates with you looks really similar, it is more behind the scenes. Of course, the computer's more powerful, and the way that things are done are for example, these days, much more sophisticated security and networking and dealing with hardware, which is far more powerful. But it is the most unambiguous and clearest way to communicate with a computer. And so we have this, what seems like a kind of stasis, but that's kind of a good thing, which I shall demonstrate. Okay. So there are plenty of kind of metaphors about how computers work, but the one which finds its way into actual computing language and the terms we use, we actually do use the word shell and we use the word kernel to represent different abstractions. Abstractions is kind of a difficult word to get your head around it, but it's trying to isolate different layers of the machine and what they do, because we have a whole hierarchy of layers of communication between, at the very base, we have the hardware. So we have the actual metal, the silicon. We have essentially a computer is just an enormous set of logic gates, and you're trying to put information through it and understand its output. But you need to connect this metal and electrons all the way up to the actual user themselves. So we have these layers. You have the hardware and then the kernel. You might have come across a Linux kernel. And then we have an operating system, for example, Windows or Mac OS. And although you might think Mac OS as being the nice looking interface, of course it has an operating system beneath that, which is far more abstracted. And then above that we have the shell, which is where the user actually interfaces with the rest of the computer. So just to make those words completely clear, here are a few notes I'll let you read for yourself. But the point is the user is communicating with the shell, and we use the command line interface to do so. And the terminal is an emulation of the terminal we saw earlier, the hardware terminal. And we are issuing commands, and the shell is letting us know what happened, and it's carrying out those commands. And the rest of the computer, the operating system, the kernel, the hardware, is not really our concern. It can be. You can, if you're trying to work deeper in the machine, then yes, the shell can communicate. But still, the point of the session today is that we're going to be learning how to communicate with the shell using a terminal to do so. So I introduced the word prompt here. The prompt is something like this. You might have seen it before, and it can look kind of intimidating. But this is it's like your workbench. It's where you put your commands, and it's so when when the command line is giving you output, it will put it below above the prompt, and then it will return your prompt to you. So it's your tool. It's your tool bench. So just to quickly have a look at the anatomy of what's on the command line prompt, as I've kind of spelled it all out here. it starts with telling you who you are. It has an @ symbol to tell you the next part is a location, in effect. So it's telling you at this computer, and then it tells you where you are in your actual directory. So in a moment, I'm going to demonstrate the difference between the working directory in the graphical user interface. So with, say, Finder on macOS or Explorer on Windows. And Linux has several different types of file managers, but they all look pretty similar. And then this $sign means I'm waiting for a command. It does mean something else, but I won't get into it now. It's telling you that you're a standard type of user. You can have a slightly different prompt if you're the root user, so you have more power over the computer, but that's kind of dangerous because if you're root, it's easy to break things. And then you have an empty space. You might have a flashing cursor, you might have a flashing line, you might have nothing. I think that there are all different kinds, but this is where our commands go. So there are several quite common shells which are in use today. So there's bash, that stands for born again shell. An original shell back in the 70s was called the Bourne shell, and then I think in the 80s or 90s it was rewritten or something. I'm not quite sure, but it was called the Bash shell, and that's very common on all systems. It's probably the most used shell there is. There's also shell just called sh, as in sh, or at least that's how I pronounce it. I'm not totally sure how other people pronounce it. On Mac OS, especially modern Macs, or perhaps almost all Macs now, they use Zish, or at least I pronounce it Zish. It's ZSH. I think that Americans call it Z shell, and some people might call it Z shell. And all of these are really very similar. Zish is it's got a lot of people who contribute to it, and so it has some really useful features, especially for the modern way of working in terms of collaborating on version control like Git. If you don't know what that means, don't worry. I can talk about it a little later on. Over the next few minutes, I want to check that everybody has a command line of some kind working. So if anybody is having any issues, can they post in the chat? Oh, I guess there's one more thing I should mention about shells, now that James has just mentioned PowerShell. So Windows is significantly different from Linux and macOS and other Unix-like operating systems. And they kind of diverged in the, I guess, the 80s or so with their own proprietary operating system. So DOS, which is a disk operating system, and it's only recently that Windows has really moved back to being a little bit closer to Unix-like systems. They provide a shell called PowerShell, and 60% of the commands we're using today will work the same in PowerShell. And I imagine in the future it will become even more compatible. The commands which don't work in PowerShell you can install, but that is beyond the scope of this course. Microsoft, of course, purchased. Well, I say of course. I know this because I'm software engineer, but Microsoft purchased GitHub, and GitHub is a place where people collaborate on shared code. But this means that because a lot of what's done in Git is written on Unix-like systems, that more compatibility is really demanded from the Windows kind of ecosystem. Therefore, we have something called Git Bash, which is it runs Bash as the name suggests, and it allows us to enter these commands that are Unix-like in Windows. So I think I'll give a very short intro to what we're going to be doing next, and then I'll just give you a 5 minute, maybe a little bit longer break. But before we have BBC Micro, although so James Womack has put in the chat as anyone logged in from BBC Micro. Fascinating enough, there are some YouTube videos of people using a BBC Micro to like get on the internet, and I imagine that there's probably some very low-level modifications being done to it, but it's fascinating what people can do with old computers. And I think that's actually an interesting, important point for this, is that when we're using the command line interface, which looks so 1970s, there are plenty of programs which do still run, and people do still need to run. You hear of databases or a banking system which is still using code from the 70s just because it's so there's no need to update it. You know, something is working, and then of course they have some security problem. But yeah, good question. Okay, let's get rid of this. Now, in the next section, so hopefully you might have this open already, but you're welcome to just watch it on my screen if you prefer. We've got some resources here. There are 6 pages or 7 pages if you include this first one. And what we're going to be doing is working through the exercises in here. You're always welcome to stop me and ask what we're doing. If you've, I know that lots of researchers and students often get given commands to cut and paste. So if you've been given commands and you don't really understand what they do, try to think about them in the given what you learn here, and try to understand what they're doing. And if you're Googling or you see something online and you see a command to cut and paste, always try and work out what it's doing. And that is a really good way of learning and building your confidence. So I'm just going to give you 5 minutes break, but in the next section, what we'll be doing, I will have my screen set up a little bit like this. I imagine I'll change it a little so that depending on what we're focusing on. On the left-hand side, you'll see I've got a terminal window and I've got a prompt. Yours might be a different color. On Macs, they tend to be defaulted to white. Don't worry if it's white. Sometimes they're black, sometimes they can be any color, and you can set it to be any color you like. I'll stick with black. And then on the right, I will have the guide here. You'll notice that some parts are in this kind of monotype. These are actual commands that, well, apart from this is just a prompt. It's talking about the prompt here, but we'll get to that on the next page. So, so that's what we'll be doing in the next section. I'm going to give you a 5-minute break, and then we can move straight on to this stuff. And there was something else I was going to say. I was just going to say, so if you are having any issues getting a terminal up, then just say. But I'm just going to give you a 5-minute break, and we'll start again at about 5 to 3, and we'll do some practical work on this. So I'll be back in just a moment. Okay, so let's get into some practical things. I'm just going to go over these important tips, which are on page 1 of the Introduction to the Command Line Interface. These are really important things to keep in mind, which might seem crazy to begin with, but it's really important to go over them. Firstly, the command line is always case sensitive. Everything you put in, whether it's capital H, lower h, any letter, they're completely different letters. You might notice if you're using Zish that if you put in the wrong case, it might correct it for you. That's a fairly modern thing. It's only been doing that a couple of years now. So some of the more modern terminals might kind of let you off if you get a case wrong. But on the whole, you should always be aware of your capitalization. And if you get an error, always check that first. Okay, secondly, you can select with your mouse, but you won't be able to move your cursor. This is really easy to forget. I forget it sometimes. So you'll have to use your arrow keys. And the reason for this is if you're communicating with another computer, the arrow keys are completely unambiguous. It is completely unambiguous if the arrow keys are used. But if you use your mouse and you're logged into a remote computer, how would you, the remote machine won't understand that you've used a mouse. And so it's all about making sure that things are simple and clear and consistent between different computing systems. So yes, you can't use the mouse. Tab is your friend. You can use it to auto-complete. So if you only have one file in a particular location, you can press tab and it will know, well, there's only one file here, so it must be this one, and it will complete it. You can use tab to auto-complete commands, but commands are often so short that there's no point. They're often 2 letters long, and it will give you more options than if you didn't press tab. But just in case, you might want to look at what options are there. If you press tab twice, then it will list all of your options that you could have. And if you're using Zish, if you press tab twice, then you can use the arrow keys to actually move between the different options. After you've written a couple of commands, you can use the up arrow to rewind. It goes back 1 step with each press, and then you can press return to do the same thing again. There isn't really anything today which could stop your terminal, but if you ever run something and you didn't want to run it, you can do Control-C. And finally, if you want to exit, you can press exit, and that will close your session. Okay, we've been through opening a terminal, so I'll skip over that. And we've been through what the prompt looks like. I will come to this symbol in just a moment. Here's a really important thing to understand when you're starting to use the command line interface, is that there's a very simple syntax, which is verb. Your command is a verb, it's a doing word. And then sometimes it might just be the verb by itself. And then you have the object, what's being done to. And then sometimes we'll have adverbs. How do you want the verb to be done? So that translates to your command. These are called flags. They are also actually arguments, but don't worry about that too much. We're going to call them flags in this session. You might see on some other resources that they call these arguments. I suppose flags are a subtype of argument. And then what you're doing it to is also the arguments. Argument is a really confusing word. So for native speakers and for second language or third language speakers, it must be extremely confusing. I guess it's from the history of computing, where argument, or maybe it's mathematics. Is it? I think it's mathematics. They use the word argument in a strange way. On the command line, we rarely call this an argument. We would just you just say what the file is. Normally a file that you're running it on. However, if you do after this move on to say computing like Python or C++ or then the word argument is used a lot more in programming as compared to the command line. Okay, so we'll make this a bit clearer on the next page. There are some more details here, but I'll let you read those in your own time. So at the bottom of each page, we have a quick guide for all of the pages that we have here. But for now, we're going to move on to our very first command. So I think the first thing to really realize in the command line is that for many of your commands, especially your first commands, you just want to know where you are and what's here. So I've called this page navigation or looking around and moving around. And the first thing we want to do is find out where we are. So try running this command called pwd. And in my case, it gives us our output. So anything which isn't the actual prompt or the command you've put in is called terminal output. So here, the /home/89362, that is terminal output, and it's put it here. And while I said earlier that you can't use a mouse to move your cursor, you can use your mouse to select and cut. You can also paste. If you're on Windows, it's right-click to paste, or I think it's Shift-Control-B, which is slightly confusing, I appreciate. Okay, so we've been told where we are. This is called a path, and it tells you in relation to the whole file system where you are on your computer. I can do something similar in, what's it called? Let's, for example, go here. Oopsie. What have I done? Nope. Okay. Let's go in here. I'm just gonna open a new terminal because this particular terminal is actually on a different machine. Here we are. I've opened a new terminal here at the bottom. You'll notice it's got TTY, so we heard that earlier from teletypewriter. It's calling this teletypewriter. Oh no, this one is teletypewriter 006. I presume this one's 007. Notice that my prompt actually looks really different in here. This is Zish, and it's just showing me this little symbol here. This is called tilde. Tilde means your home folder, so it's telling me where I am. Now, I'm actually skipping ahead of command I. It's very difficult to get these in order. Let's say we're going to run the second command here. I know, where is it? Oh, let's quickly go through these. So these are some shorthand that you'll see quite commonly. Tilde means your home folder, or people just say a home folder. Dot means here, and dot dot means one folder back. Dash, don't worry about dash too much. Dash means the folder you're most recently in. Now you might think that that is identical to the folder above, but you can move more than one folder at a time, and you can flip around the operating system. And then this slash means root. Root is the folder which contains the entire computer. So in Finder window, if we were, you can see here, we have, I think they call it breadcrumbs, don't they? I never use that term because it's a bit weird. But we have this folder called code, and then we have, oh, it's also telling me about snacks too because I've selected it. And then it says that's inside 809362, that is inside users, and that is inside Macintosh HD. So Macintosh HD on my local machine is effectively root. That is your /. Okay. Now, I have skipped ahead. I hope that isn't confusing. I skipped ahead by doing ls. And the reason I did ls is because it will quickly become muscle memory to write ls absolutely everywhere. And it'll be really irritating because you'll put it into messages by mistake. I do that all the time. I'll just write ls and people go, what are you talking about? And I go, oh, sorry. I thought I was on the command line. So ls. This is asking us to list everything that is in this location. And what you'll notice is that these two things are effectively the same. So code, I'm in, can I make this like that? So you'll notice that all of the items in here are listed in here. It's effectively the same. It's showing you in a completely cut down plain text way exactly what's in this particular location. So that's ls. It's probably the command you'll use the most. It's basically look, see, have a look here, show me what's here. Okay, and then, okay, I'm just going to get rid of this terminal at the bottom. I just wanted to demonstrate the similarity between the Finder window and the output of ls. But I want to get rid of that because I only want to use this particular terminal. I want to clear that. Okay, so let's do that here, ls. And then I couldn't get the formatting to do blue, I'm afraid. But I mentioned here that items are blue and white. On the left, you should be able to see that I've got some things in blue, some things in white. Things that are blue are folders, so we can actually move around them. However, the first thing that we're actually going to do is we want to make a location where we can do our work today. So we're going to use another new command, which is mkdir, make directory. And we can do that here, as long as I haven't already made it. Let's do that. Intro to CLI. And you'll notice that the command line doesn't do anything. It just goes, okay, here's a command prompt again. If you don't see anything, that means it's fine. If an error has happened, you'll pretty much always have it telling you that there was a problem. For example, if I did that, then bash, it says, here's bash talking, and it goes mkdfir command not found, which is a fairly clear error. It just goes, I don't know what you mean. That command doesn't mean anything. However, we did run mkdir, and if we do ls again, we can see that we have a new folder called intro to CLI. One thing I didn't mention earlier is that spaces. So there are certain characters which are generally well, you should avoid on the command line. There are plenty of them which might be obvious. For example, equal, /, percent, $, all of these kind of punctuation and those kind of characters the command line won't like because it's already using them for particular things. Also, the space is something that the command line, it does, these days it does work well, but it's if you use it, you then have to do slightly special thing. I'm just going to quickly demonstrate. In fact, I'm not even sure how to do it. Spaces here. I have to put it in quotes because it will think that I wanted to make a directory called spaces, and then it will go what is here. But if I go like this, you'll see that I've got a folder called spaces here. But if we then move on to the next command, so maybe some of you moved on to CD. So CD is change directory or change folder. Whenever I say directory, it's the same as folder. If I then go CD spaces here, you'll see that it's put in, so I tab completed then. So I got to SPA and went tab, and it completed it because it couldn't have been anything else. And it's put a backslash here. That's called a escape character. And it's saying that the next character you see is literally that particular character. If that wasn't there, it would go, there is no place like this. It doesn't exist. Whereas if the backslash is there, oopsie. I don't even know a backslash. Then it will move into that directory. Anyway, the point is, stay away from spaces because you might come onto some systems if you're logged into a different computer which doesn't like spaces. So use underscores or hyphens. Either of those are fine. Okay, now I'm just so we're going to move into this folder. So we can go cd in and then tab. So then we have this command cd, which I guess we've looked at. That's change directory. And you can mention any directory which is in the one that you're in. If it's not here, in this particular directory, it'll go, I don't know where you mean. So there's a command called clear if you are getting confused for the output, which will give you a new, it'll kind of refresh everything. So if I do ls, it says nothing because there's nothing here. So if you remember from the kind of anatomy of our prompt, we have our name, we've got the name of the machine that we're logged into, and then we have a colon. I noticed earlier that I think Zish has just got a space there instead, even after I've just said how terrible spaces are in the command line. I think it's got space rather than a colon. And then we've got tilde, your home directory, / intro to CLI, and ls says nothing. That's fine, it is actually empty. You can try doing a pwd here if you want to see how things change. That's print your working directory, and then you'll get a full a full path from the root to where you are. So there we are. On this page, we've covered how to see where you are. That's pwd. It gives you a full route. A path of where you are, and then we can do ls to have a look. We might see nothing, and we can do cd. Okay, so I also skipped over cd ... So remember from earlier, ... means one folder back. So if you do cd ... then we'll get back into your home folder. You can try going cd ... again, and again, and again, but you'll notice that it stops after a while. That's because here we are, we're in root, so we're in the whole file system. If we do an ls here, you'll get these very difficult to understand names of folders. These are the folders of your entire computer, so absolutely everything on the computer is here. Most of these are protected, so you won't be able to change anything that would break anything. But one way of going back to your home folder is just to go cd. So if you just go cd by itself, you always go back to home. your tilde home folder. We can do ls again, and you'll see that I'm not in root anymore. And I'm going to go into intro to CLI. You'll notice that when I tab complete, oopsie, let's clear that. Actually, let's bring this across a bit. I don't want it to be confusing. Let's go back one. If I go tab complete, it puts a slash at the end. That means it's a folder. Anything ending with a slash means this is a folder, not a file. Also, if anybody is migrating from Windows, cd ... doesn't have a space back on in DOS, and it's really confusing. But yeah, there's always a space between cd. So cd is a command, and it'll always have a space after it to say that's the end of my command. Here are the arguments or flags of what I want to do. Okay, so we have this fresh, empty folder, and what we're going to do is we're going to bring in some of the course materials. So if anybody's got any questions at this point, always put them in the chat. Let me see if I've just missed anything. Okay, that looks cool. So hopefully you're looking at this page, copying, moving, and deleting. And to give us something to work with, what we're going to do is bring some files into the directory, the folder that you're in. And what I'd like you to do is to cut and paste this line. Now, don't worry about this command. It's slightly more complex than the rest of the stuff in this course, but all we're doing is we're bringing something down from the internet. So curl, it's going to a particular URL, a location, and don't worry about this flag yet. We'll talk about flags in a moment. And then you're just giving it a URL to bring things down, and you'll have a zip file. So let's try that. Triple click will select a whole line. If you ever see something scrolling miles off, don't try and do this all the way. You'll always miss something. Just do a triple click. Okay, and then we can put that in here. So I've pasted it in here. Don't worry that it's going over the edge of the line. Let's clear this up. Oh. Yeah, paste it in here. And you'll see it does something, gives you a few stats on what it did. It's downloaded 2 megabytes. It's really 2 megabytes. And now, if we do an ls, we can see that we have this file called command line files.zip, and we're going to unzip it. Again, this is just one command, which is kind of beyond the scope of this course, but it's just to get us all on the same page. So if you can cut and paste this command here, and we're just going to go, oopsie. So you'll see that the command line is filled with output. So this is telling you everything that it did. So this is classic output on the command line. So it made some folders and it expanded some compressed files. And if we do an ls now, we can see that we have the zip and we have the command line files. So this is exactly the same as double clicking an archive or double clicking a zip if you're on Mac or Windows respectively. Now what we're going to do is we're going to go inside the command line files folder. So we can do cd command line files. I've tab completed there. Go return. You'll see it's been added to my path here. And we can do ls. And you'll see we've got 3 folders: example files, sandbox, and some plays. Just going to clear this again. Okay, so I think that for the next few minutes, I'll just let you have a look at the commands that I've talked about here. Here are Yeah, try middle click or right click if you're on Windows. So we're going to be using 3 really important commands here: cp, rm, and mv. CP and RM are crucial. MV is you won't use it so much, but we'll get onto that in a second. In fact, I'm just going to leave you for a few minutes, like let's say 2 minutes, to have a look at the instructions I've given you here. So it starts with moving into Sandbox. So I'm sure you can figure that out using CD. And I'll just give you a couple of minutes. So you're probably noticing that these are all similar to things you do on the graphical user interface. So you can copy things, you can delete them. So RM is the same as delete. And it's repeated throughout this course, but the command line always does what it's told. So if you delete something, it will delete it. You don't get a recycle bin. You don't get any, it doesn't ask you permission. But you can set it up so that it does ask you permission. But I think I'll add that to the notes later because I don't want to confuse you. But always be incredibly careful. So like I mentioned here, CP data 1, data 3, if data 3 already existed, then it would be overwritten and it would just do it. It wouldn't even ask, it just does it. So I hope you've all had time to have a look at this page, talking about moving. Moving is, it can be another dangerous one. If you move data 1 to data 1, data 4, if data 4 already exists, then not only will data 1 overwrite data 4, but data 1 will no longer exist. So it's I always find it safer to CP. Okay, so there we go. That page was about copying, moving, renaming, and we've also, remember earlier, we made a directory. So that's plenty of the things that we can do in the graphical user interface as well. Okay, so the next thing we're going to do is we're going to have a look at actual file contents. So let's move to the next page. Okay, so first of all, we're going to move into the folder called example files. You might find at the moment you're already in Sandbox. So figure out how to move back and then move forward to get into the right folder. And we'll have a look at files there. I'll just mention a couple of things at this point. Firstly, your prompt can get very long, and in many modern systems, it does get abbreviated. You might just see just the folder, the name of the folder you're in, but without all of the stuff which comes before it. Because if I was another few folders deep, then your prompt can fill the line, and it can be kind of irritating. Also, just briefly, you'll notice that in the last command that I did, so if I wanted to get from Sandbox and I wanted to get to example files, you could do it in 2 commands. You could go cd ... go back 1, and then cd example files. And there we go, I'm inside example files. Instead, you could do it in one move. You could give the relative path, but all in one command. So if I go back, in fact, I've already done it once. There we go. If I could go cd and it's ... and that is a folder, so it ends with a /, and then I can go Sandbox and I can go tab complete. You can tab complete from anywhere. You could be miles away from the folder you need to get to. It will still understand. it'll still understand tab complete. So there we can give that path, and I press return, and oh no, oopsie. I want to move away from Sandbox, back into example files. There we go. I've moved 2 folders just with 1 command. I'm just going to clear my screen here. Remember, clear or even Control L will clear your screen. Now, cat. I'll talk about cat for a second. Cat means concatenate, and it means put the file into your terminal window. Hopefully you've had a go at these too, and you've seen that it does as you tell it to do. So if the Tempest was one big file of the human genome, it would just print the entire thing to your terminal, and it would take ages, and it would take up lots of RAM. At least for a second, it needs to put all of that into RAM. So often we don't really want to put contents of file into the terminal window. So have a go at these commands here called head and tail. Okay, so you might have had a go at head and tail. Head and tail, this is a really good introduction to some terms you'll see in programming. You'll have seen that head is show me the top of the file and tail is show me the bottom. Now Alexa asks, why is that minus there? So the minus, that makes total sense, as in, why is it not a positive? Why is it not just a number? It's because the syntax is a flag starts with a minus. In fact, there are some there are some exceptions which you might get used to, but I won't talk about them now. So that is a flag, and the flag is being started with a minus. If you're looking at YouTube videos or when you hear people talking about commands, people will say it in different ways. I think most British people say minus. So, for example, earlier we did we copied a folder. If you went through the page before this, and we said CP minus R. Now I would pronounce that CP minus R. I know that some people say hyphen R. I'm not sure if there are other pronunciations. And in this case of head minus 35, I would just say head 35. The point is, in answer to your question, is the minus is saying this next bit is a flag. It's an adverb to describe how head is being done. You can try doing it without the flag and try and work out what it's done. And but yeah, that's the answer to your question. Yeah, Alexa, think of it as a hyphen, but be aware that people will often say minus. I don't know. I'm going to ask from James and Emma, what do you hear more commonly in terms of flags? Is it minus or hyphen? Personally, I hear minus more, and I say minus more. Oh, dash. Oh yeah, good point. I forgot dash. Dash or hyphen or minus. I still say minus. Confusing. Okay, so further down the page, we've got a few more command switch which put out output into your terminal window. You've probably figured out what they do by now. Tac is cat backwards, so it puts out a file in reverse order. Rev is reverse it by character, so the entire thing becomes reversed. Unique. I know it says unique, but unique. Okay, so Mark, it looks like you might be in the wrong folder. If you go cd ... and press return, then you should be in the folder containing that. And then if you go cd example files and then press return, then you should be in the folder with, yeah, as James says. Let us know if if you can't find the right folder. Okay, cool. Okay, and then the last thing on this page about viewing file contents is using what we call a pager. And the main one, there are different programs which act as pages, but the most common one is called Less. Why it is called Less is a history lesson for another day, but that's what it's called, Less. Now, if you run this program, Less the Tempest, you'll notice that the screen changes very, very slightly, but you are no longer on the command line. You are in the pager. So Alexa, okay, don't worry about that. So you must be on a system which doesn't have Rev installed. Don't worry about that too much. Rev is not exactly something that people use all the time. I think later I will modify the final pages of this course to tell you how to install, or at least the very basics of how to install programs. So, so where Alexa gets bash rev command not found, the command isn't there as it says, but it's something that can be installed with a quick command, but I don't want to confuse things right now. So don't worry about it too much. Basically, it just prints out things to your terminal, but it does it backwards. And just briefly, you might hear me saying the word print very often, and this is another historical thing. Remember, we used print working directory and print to the terminal output. Remember that from the history lesson we had earlier. Oh, I've closed it, haven't I? But we saw that the people back in the 60s and 70s would actually have a terminal with a printer. They wouldn't have a screen, and absolutely everything would be printed out. So that is another historical thing where people will say print, and it sounds confusing because it sounds like you're sending it to a printer to go onto paper. You're not doing that. You're putting it into the terminal output. And many programming languages, if not all of them, will still use print to mean just output onto the screen. So you'll see that in Python and not C++, I don't think, and plenty of other languages you will come across. Now, one thing you'll notice about being inside Less is that if you type in a command, it won't do anything. It might give you a strange error along the bottom. Let me just quickly do it. So my terminal is here across the bottom. I'm going to go Less the Tempest. And you'll see that I can scroll down. There is a colon at the bottom, and I can search. If I do / and I go, I don't know, dog, then it's found the first instance of dog. And there are plenty of commands that Less can do to search for things and, I don't know, tell you line numbers or whatever. But you'll notice that you can't, if you wrote in if you try to do CD, it just doesn't even let you do it. It just moves the page around. But if you want to exit, you press Q. Okay, so don't. So if you find yourself unable to put commands in, always go, am I inside a pager? In which case, press Q. Okay, so those are some of the most common ways for looking at files. Less and cat, and head and tail. We'll get into a couple of more sophisticated ways of using these in the final page of this. But for now, oh yeah, here is an example of a flag with a plus. Don't ask me why. I've never understood why Less takes a plus. But it does. If you go Less plus G, I I won't go into it now, but this is a very rare occasion where your flag is a plus. It's because the capital G is something that you would have done after opening less, but don't worry about that right now. Okay, so we're on the page editing files. Now, the command line is super powerful in editing, and I'm not going to introduce you to editing without opening a dedicated editor. But there are ways in which you can search and find particular matches and put them into a file and change them and create new files. But I don't want to go into that today because it can be a little confusing. Instead, we're going to run a program, and it is going to allow us to edit the contents of a file. And in many ways, it's like a word processor. So you've got Word, or I guess the browser-based things like Google Docs. Though you can write things in there, but they are very, they've got very rich formatting. You can have colors and fonts and all sorts in there, and images and so forth. On the command line, you don't have that. Again, for consistency across machines, and so that they're all working from the same page and they all understand absolutely every single character. We have editors which are, they might seem really basic, but they're very powerful in different ways, in the ways that you can edit, and you can modify different lines simultaneously, and you can do all kinds of clever searching, which things like Word can't really do. Now, I've mentioned some editors here: Nano, Micro, Emacs, Vim, or Vi is an earlier one. Again, that's pronounced in different ways. Some people call it VI. Some people call it VI modified. I'm not quite modified. I'm not quite sure. But this range is going from Nano is, in my opinion, the easiest to use of these, and Vim is the most difficult to use. But if you're good with it, then it's very quick to do quite complex things. The one that I use every day is Emacs. That is, it's very capable. It's not too confusing. It's got reputation for being quite heavy. It's quite a large file to install and run. But today we're going to use Nano. So Nano should be installed on all of your terminal emulators that you have. Okay, so try running the Nano Animals. Let's do that. I'm just going to do it to Nano Animals. Now, again, you'll see that the terminal output changes, and this is, in effect, this is another interface. It's got a kind of cheat sheet of things to do at the bottom. This up arrow is control. And you can see it is a list of animals, and much like any word processor, you can add things in. Let's add one in, wombat. And you can move around with your cursors, not with a mouse. And then, like it says in the instructions, we can, the most important things you'll want to do is save. And for Nano, that is control output. And it asks you at the bottom, what do you want to call it? And it's defaulted to the actual name of the file already. And you can press return, and it tells you that it wrote it. And we can do Control X to go back. So that is an unbelievably short introduction to editing files directly using an editor. Nano you should find installed on almost all computers. Vim is also famous for being available everywhere. Emacs and probably Micro as well tend to be things that you might need to install. But again, that's just a single command to install these kinds of things. Okay, so hopefully you've been working through this page. I'm just going to mention briefly this big difference between Windows and Unix style systems. Windows is obsessed with file extensions. If it's a .txt, it's definitely a .txt. It must be a plain text file. In macOS, in a computing cluster, in your Linux machine, the file extension doesn't actually mean anything. You can have loads of extensions, it doesn't really care. It sees it as a file. So it's quite difficult to it can be confusing to move from Windows and it not be really critical to have particular file extensions. Okay, so we're getting to the bottom of this page. Hopefully you've tried to modify a file, you can try cutting it out and so forth. But we're going to move on to searching. Let's move this over. So this course, we went the extra things. The further skills page is really an addition. I wasn't intending to go through the examples on that in person. It's there for you to look at. But given that at least Anna has asked about that, then I will have a look at that. But otherwise, this is our final page for the main content. So I will go through this page, and if there's anybody interested, I will also continue on to the further skills. The other things that I mention in further skills, so first off, there is how to link commands together. And I also very briefly touch on two commands, one called SSH and one called SCP. If you're working with researchers who use computing clusters or some kind of remote machine, you might have been given commands with SSH or SCP. So if you want those demystified, then feel free to hang around and we'll have a quick chat about that after 4. But for today, really this introduction, it only extends to making files, moving around, looking around, and this final part, which is just searching for files and searching inside files. So the first command that I introduce you to here is called find, and it does what it says. Find is actually quite an unusual command. It's got some quite unusual syntax, but have a go at the commands that I give you here and have a look at my comments on it. And I'll get back to you in just a couple of minutes. So hopefully you've managed to use find, and you'll notice that it outputs a path to where that file is that matches what you're given. And then next, so I realise I've written quite a lot on this page, but I don't want to run out of time. I'll keep you back if you've got somewhere to go. But this page is split in two, searching for files and searching in files. And this, I think, as Emma is mentioned, it's such a powerful, I use it all the time, and you can use it in so many different ways. It really is. When I first started to understand grep is when I understood the power of the command line, really. So grep's got a really weird name. You'll hear people using it as a verb sometimes. If you grep this or grep that or grepping out, it means Control F. Think of it as your Control F, but we can use it in much more powerful ways than we would do in say a Word document or a browser window. So have a go at the commands that are highlighted here. And in particular, pay attention to these ones where we look at some different flags and note the differences that it gives to the output. Anna's into grep. Grep is, yeah, for me, it really came together when I understood grep. And grep is also something you'll hear in most other languages. There are it takes things from grep. Grep is kind of the original, very powerful command. So in the course today, I hope you've learnt some history of how to understand how we've got to where we are and why we use it for research purposes and, well, all kinds of technical purposes. And then we looked at some important commands like mkdir, cd, ls, rm, and then we used an editor, we used nano. Oh, we looked at files with cat and less, and in this final part we're using grep to search inside files. Now, the commands that I've just mentioned are literally 95% of what I do on the command line. And if you've got those, then you're in a really good place to start. If you want to go further using computing clusters, or you want to understand like submission scripts, you might have seen if you use Blue Crystal. It's understanding this logic of verb and object, because it's all very similar. Once you understand how these work, then submission scripts in particular. So a submission script is something where you ask a large computer to submit a job, and it will do the commands which are inside the script. And often the commands inside the script are all command line commands, and you can work out what it's doing. You can understand why things broke, and you can try and work out how to get things working again. So, like I say, if you've followed through this very few number of pages and you've understood what's happening, then you really have covered an enormous amount. So that's great. It's 4 o'clock now. I'm going to hang around because I want to see if anybody has got time to have a look at the advanced topics here. The further skills, but if anybody has to go, then thank you for being here. Okay, so Anna wants to look at the further skills. That's great. So one person is enough for me, but if anybody else, oh no, it's absolutely fine. Yeah, Anna, definitely got time. So let's have a look. But for anybody else who does need to disappear, we do of course have you can contact us on ask, which one should I give you? I'll give you ask. So ask-rse@bristol.ac.uk. You're welcome to ask us questions there. We can point you towards resources or try and solve any problems that you're having. Okay, so how are we with... So I totally skimmed past all of this wildcard stuff. Does anybody have questions about wildcards? I think that the crucial bit here is to understand that you can use it to search across your file system, but also inside using greps as well. I'm going to go to further topics, but really there are there are 3 main topics here. The first is a concept called redirection or redirecting. The second is a concept called pipes. And the third is related to how we log into remote machines, which can be really confusing. So this is where the command line really becomes powerful. And if you understand these topics, then it's you're really on your way. Especially, I know that somebody was here for, say, bioinformatics, which involves a great deal of picking out information. So if we're looking at redirection and pipes, then you're doing really well. I mean, I was using the command line for months, if not 6 months before I discovered redirection and pipes. The first one, redirection, is to take the output of your last command and make it the input of a file. So far, when we have done our commands, in particular the ones for putting the contents of files into the terminal, it has done exactly that. It's just put it into the terminal output. Let me move to a folder where I've got something. It's confusing because I've got it so large. Let me let's put this over here. Okay, let's clear this. Okay, so I'm in the folder example files. Let's look at plants. Okay, so I've cast it to the screen. It puts everything there. And that's all it's done. It's just put it into the output, and nothing else has changed. Let's try just looking at the first 2 lines. Let's go head -2 or -2 or -2, and let's do the same file again. So this is going to give us the first 2 lines, oak, elder. But if instead we didn't want oak and elder to just go out to the output and the computer to just go, there you go, finished. If I press up, remember you can go up and down to look at the commands you've done in the past. So here we have head -2 plants.text. Now if I use this symbol, the kind of greater than sign, I just think of it as an arrow personally. And then we give another argument. And you're naming here the file that you want to send it to. So let's call it to plants. I go return. So the command that the terminal hasn't said anything. It's just gone, okay, here's your prompt back. It's because this is called redirect. You might hear people saying this as head -2 plants.text redirect to plants. Otherwise, other people say send to or just to. That can occasionally be unclear. You'll see it didn't give me any output, it just went okay. But now if I do an ls, we can see that we have a new file here called 2 plants. So we know, and if we have a look at the contents, oopsie, we don't want that at the end there. So if we cat 2 plants, it'll go oak and elder. Notice that when I did that mistake and put a square bracket, it thought that was the name of another file. It went, here you go, that's the contents of 2 plants. And then it went, the contents of your closed square brackets that doesn't exist. Okay, so that's a nice start. Now, there are probably warnings peppered throughout my documents here. But yeah, here's one. Oh, it needs a little exclamation mark. I haven't done that. Just like with everything else, if 2 plants already exists and you do a redirect over it, then it will overwrite it. So Anna is asking, what type of file is 2 plants? And you've gone, how does it know that it is .text? So earlier I was mentioning file extensions, and in Unix or Unix-like operating systems, which is what we're all using, whether we're using Git Bash, whether you're in a Jupyter Notebook, whether you're using your Mac terminal, whether you're using Ubuntu, we're in a Unix-like environment, and the file extension like .text or we don't have any other examples here, but I don't know, .pdf, .xls, .docx, I guess is what Word uses at the moment. Those that are relevant to a Unix system, everything you see. This is slightly misleading, but this is kind of true, that everything is either a command. So here you got head or ls or cat, these are all commands. Everything else is a file, and in this case, they're plain text files. Now you will have different types of files, and of course the one which is confusing, particularly to newcomers, is binary files or executables. On Windows, you call them executables, and those are things which, instead of containing information that can be viewed, it contains instructions that the computer will actually run, if you ask it to run it. So in this case, I didn't need to call it. Yeah, my point is that you could call files anything you like. I could have called it 2plants.pdf. Now, if I go cat 2plants.pdf, it will still do it. It doesn't matter. I could call it a PDF. I could call it an MP3 file. If I cat it, it will go, okay, that's what's inside. And I think that is part of the strength of Unix systems. Is it just does it. It doesn't have assumptions about what the file contains. Whereas Windows is very strict, and it assumes that a text file must be text, or an MP3 file will be compressed audio, and so forth. So yeah, file extensions, you can call it anything, and also you can call things multiple things. You could call it .pdf, .old, .text, .plants.to, and that's absolutely fine as well. Okay. So, are there any file types for which it couldn't see inside? So, if something genuinely was, okay, and just okay, what I'll do, I'm just going to clear the screen. Actually, yes, I don't have the right file types here to demonstrate, so I'm just going to exit. So, I'm back at my own machine. Let's go. Don't worry about the contents of the screen at the moment. I'm just trying to find something appropriate. I'm not sure I have any music in there. This music. Empty.
Al, you've got some zip files up in there somewhere.
Do I? Where are they? Oh yeah, here's one. Nina 15 June zip. Okay, so Nina 15 June zip genuinely is a zip file. So if I try to cat it, let's see what happens. Now you're going to get, at least in your beginner days, you're going to get familiar with stuff like this. The terminal is trying to show me binary content. So it's gone, this is a zip file, and a zip file is not plain text. Ah, it's gone crazy. It's tried to actually print it to my printer. That's crazy. Let's stop it. I'm going to do Control-C because this will just go on forever. So that file genuinely was a .zip, which is a binary file. It's got nothing to do with plain text. And the terminal went, okay, fair enough. And it puts all of this rubbish to the screen, which is all binary, and it can't really render it properly. It just goes, well, this is what it is. I don't really, I'm not a computer scientist, so I don't really know, but yeah, symbols like that, odd. Oh look, a Chinese character. So are there any types of file which it couldn't see inside? Well, I don't know. I guess not really. It will always show you what's there, but if it's a binary file, then what you see there is just not understandable for the terminal. So I hope that kind of I hope that explains it. But if I haven't, just as if output answer my question. Yeah. Okay, I'm just going to go ignore the commands I'm doing right now because I'm just going to a machine which is consistent with your one. And I'm going to here. Oopsie. Example. No. What is it? Command line files. Example. You can see here that I'm moving 3 folders in one jump, so I can put the whole path, at least the relative path of where I'm going. Okay, so we're back here. Yeah, so Emma mentions, so isn't, if you try to head, so an XLSX, that's a Excel file, I believe. And if you try to look at that, it will show you nonsense because it's designed, I think that's right. Someone correct me if I'm wrong. But if you try to cat or less an XLSX, it will go, here's all the stuff which Excel needs to see. All my formatting, when it was the last updated, all of this metadata. In fact, there'll be much more metadata, usually. There'll be, well, sometimes there'll be more metadata than the actual data itself. And there'll be all of this crap which Excel needs to know, but you don't need to know. CSV is short for comma separated values, and that is a format which Excel can save as, which is essentially your raw data, and each of your cells is separated by a comma. And if you go on to do, say, programming in Python, so the format of, say, a CSV is kind of similar to what we call a data frame, which is used in Pandas. Pandas is a library for data science in Python. And Python and R can work. R in particular works with CSV files, and as James says, head and tail and sort and these kind of commands all work. Oh look, fun fact, I did not know that. They're actually zip files. There you go. I did not know that. So there you go. Each time Excel or Word needs to open something, it needs to decompress it, or at least turn it into a format that it can understand. There you go. Interesting. Okay, where are we? Okay, so that was a bit of a redirection from redirection. So redirection is putting the output of one command into a file. Now, so I hope that makes sense. If you've got any questions, put them into the chat. We're just going to move on to another really major concept. And if you've got these two, then you're really on the way to getting the command line. So the next one is called pipe. So I've skipped down the page a little bit because I mentioned a few more things. Oh wait, I didn't talk about appending. Okay, I'll quickly do that. So the commands we did earlier. Also note that your history is persistent. So these, I've actually exited this this terminal and gone back in, but all of my old commands are still here. Let's go back to this command, head -2 plants.txt, redirect into the file 2 plants. Oh, let's keep it simple. Let's call it 2 plants. And it doesn't have an extension. If and then if I look at the contents of 2 plants, we have oak and elder. If we did the same thing again, nothing changes. All it did is overwrite it. Instead, what we can do is append. So that's double greater than sign, or double little arrow, angle brackets sometimes they're called. Now if we do that and we look at the contents of 2 plants, it's added to the end there. Now that in some ways this I often use append. If 2 plants didn't exist at all and you said append to file, I don't know, let's just call it file 4. If file 4 doesn't exist, that's not a problem. It'll append to an empty file. So if we now go cat file 4, that's fine. It appends. And often I use append much more than I use redirect because it's safer. Because if you redirect, it overwrites. Append only ever adds to the end. So I often use that much more. So perhaps if you get into making log files, you might append to it. But redirect is another warning. Much like CP or MV, you can lose data. So be aware of that. Okay, so that's append. And then we're moving on to pipe. I introduced a new command here because I'm sure you can take it. This one is called WC. Got nothing to do with water closets. It's about word count. And word count is often used to count lines rather than words, although it can count words and characters and all sorts. But it's useful for demonstrating pipe. Is that what I do? Yes. So the critical difference between redirect and pipe is that redirect is creating a file. It's creating data and it's writing stuff into it. Pipe is instead sending it to another activity, another verb, another command. You are sending the output of the first command in as the input of the next command. So I hope you've had a try at this and you've noticed what it does. And unless you're doing a redirect, it will output to the terminal window. So let me just move into the right folder. We're going into some plays, aren't we? So I'm just going, for those that are interested, I'm just going to introduce you to a couple of flags on LS, which are useful. If I do LS, normally I just get them blocked, all as many as can fit. If I go LS and give the flag -L, that means line by line, which you'll notice the same with word count. If I go line by line, then it puts one on every single line and gives you a great deal of detail about the file itself. I won't go into what these all mean, but I'm sure you can figure it out, or at least much of it. This first bit is kind of confusing, but I won't go into it now. It's about the access rights you have on the file. Now what are we doing? We are doing. Okay, yeah. So let's do the word count, and let's just word count by line Hamlet, and it says 5,877 is the output. Okay, that's handy. Yeah, so Emma mentioned it's really also a shortcut. I'm not sure it works. So the system I'm working on here is CentOS. I don't know if this works, but certainly on Zish and Modern Bash, we do LL as a command. Oh, it does work. That's great. So just LL will give you, we'll do it by line. I think, is it LA? LA doesn't work. I think in Zish, if you do LA, it gives you more detail or something. But there are several of those, and there are lots of flags, which I won't go into now, but I'll give you resources of how to find out what they mean. But one I used to always do is that or something. No, I don't need two H's or L's. I used to think I needed all these flags. So here you can see I've got multiple flags, and that is byline, sort, in reverse, human readable. I don't know what T means. Oh, give me the time. I can't remember now. Anyway, just demonstrating you can put multiple flags. Human readable is a really useful one because here it's told you how big the file is in kilobytes or megabytes or gigabytes rather than actual bytes. If you don't have it there, then it tells you how big it is in bytes, and my brain doesn't work in bytes. Okay, and then we do a wildcard. So let's do So there we go. WC minus L and star. Just looking at the questions. Okay, yeah, I should have mentioned. So Alexa, you're looking for pipe or the vertical bar. On Mac, it is next to the return, at least on European Macs. I know that American Macs, it can be somewhere else. So if your return button is two characters high, that's called an ISO. That's an ISO layout, and it'll be next to it. If you've got a return button which is only one high and really long, that's called an ANSI. It's the American version, and your vertical bar will be somewhere else. On Linux, it can be the character next to the 1 up at the top left of your keyboard, and it can also be down by the Z. It can be to the left of the Z. Let me know if you can't find it. I know it's kind of irritating. Yeah, James is giving some help there. Let us know if you can't find it. Anyway, I'm labouring this point, I realise. Okay, so we did word count minus L star. So star means all of them, and we've got all of the amount of lines, and it helpfully tells us the total. But then we can do a pipe. Let's pipe that into sort. And you can see for yourself what it does. And if you like, you can give sort a flag of minus R. And I'm sure you can see for yourself what that does. But usefully, see that minus R earlier with like CP meant recursive. With sort, it means in reverse. So that's a good example of flags meaning different things to different commands. And then finally, in this example, we have a pipe and a redirect. So I'm sure you can figure out what that does. So yeah, just briefly as an aside. So the command man is short for manual. Got nothing to do with man's. Because it's got all the manuals, I always think of it as being mansplaining, which really irritates me. But you can go man for any command. So man ls, and it will open a pager just like less. You can go up and down, and it will give you absolutely every detail about that particular command. Often these are written really difficult, that they are difficult to understand sometimes. However, I do really recommend you have a look at these because when you understand the kind of language that the computery people use, then it helps you read. Like if you Google a command, you can understand things quicker if you've kind of got a little bit of experience of looking at man pages. So that is man. I was just fiddling about, so I was trying to make a really complex command, which I can't do without doing something which is beyond the scope of what we're doing today, and I really don't want to confuse you. However, I guess I can just... So say if you just wanted to isolate just the number of lines per each of these plays, I've got a kind of... I realise there are things here which I haven't explained, but the point is that I can pipe into pipe into pipe into pipe and do all sorts of silly things. So here I'm going word, count all the words, count all the lines in every file, pipe the output into a command called awk. Awk is amazing, but it's beyond the scope of this course. Ask, tell me just the first field, in this case it's the first word, and sorts those. And then I was looking to see if I could find if any of the plays had identical number of lines, which they don't, so don't worry about that too much. But let's say, for example, that's what I wanted, and I could go sort and then redirect and go lines. And then I can go cat lines, and I've got, oopsie, cat lines. And there you go. I've got a file with an ordered list of the number of lines in each of the files. That 0 there is because it tried to count the number of lines in my command. That's the type of error that I do. This number is the total number of lines. I am totally waffling. It's past, but I am really going to very briefly mention SSH. You're very welcome to be here for this or not. Oh, I give you all these, don't I? I forgot about that. Yeah, have a look at those. Some of them you won't have installed, but they're really useful. History is incredibly useful. In fact, I'm going to tell you about that now. So here I am. If I do history, right, it puts to screen absolutely everything that I've ever done. And that's really useful. Here's an incredibly useful grep that is really useful. But you can go history, pipe, grep, and let's say I thought to myself, oh yeah, I remember 2 days ago I did that command using awk. I know I haven't gone into awk today, but some other day. And I can go history, pipe, grep, awk. So the output of history, find everything where I mention awk. And there you go. I've got all of the commands. And I go, oh yeah, 3 days ago I did go that command, and you can cut and paste it and do it again. So history into grep. That is incredibly useful grepping. Okay, very finally. So I'll let you figure these out for yourself. Some of them won't be installed. History is incredibly useful. Sed is incredibly useful. The rest of them not very useful. I just put them there to confuse you. Okay. Now this is something I just want to really briefly go over. I realise it is now 25 to 5, but this is something that we get a lot with people asking for help, is they've been given a script which has SSH in, or they've been told to do something with SSH. So I'll really briefly just talk about what it is. So we talked about shells right at the start of this session. SSH is a command which runs a secure shell. So it's used for opening a shell on a remote machine. Oh, Emma mentions cut. Cut is really useful as well. You'll if you're Googling things, look up the most common or the most useful command line commands and have a play with them. Anyway, SSH, so it means open a secure shell. It means basically log into another computer. And it can be really confusing. So I'm just going to clear the screen here. In fact, I'm going to exit completely. And open a completely new terminal. So for me, that's item. Let's run an item. And let's make it a bit bigger so you can see it. So this is my local machine. It's in Zish, and so it is showing things slightly differently. It's got tilde here rather than the full prompt that you might have. But I can move into a different machine really quickly. So for today, I've been using a virtual machine, which is probably in Leeds, I think. I can't remember. My name, 89362. And then I'm going to go at, and then I'm going to give the computer name. So here, don't worry that this is a silly, long, confusing name, but you might, if you're working with people working on, say, Blue Crystal or Blue Pebble, which are at the University of Bristol, it might say Blue Crystal login or some other computer name. This one is called app-DC1. DC1 is a data center which the University of Bristol has, which is in Slough. So when I go return, it asks for my password. So with the university, it's very difficult to do a password whilst talking. Go. Did I get it right? No. Sorry, I got my password wrong. What is the password? Deal with that in a second. Wait, one more try. Yes. So here I've gone, make me a secure shell. I want to log in as this person, and I want to log into this machine. This could also be an IP address you can put there if you know what it is. And then it asks my password, and I got it wrong twice, and it tells me that somebody naughtily got their password wrong twice. But here I am now in a different machine, so I just know, just because I kind of do, that DC1 stands for Data Center 1. That's in Slough, near London. So this machine that I've been working through today is a long way away. I don't even know where it is. However, we're now in a different machine, so I can exit by typing exit, and I could let's try going into Blue Crystal, so I can go SSH 189362 at BC4 Blue Crystal 4 login.acrc.brist.ac.uk, and I can go return. It wants my password again, which I probably won't be able to do again. And we get that. I can't get it right. Oh no, I'm in. So there we go. I gave it an address of where I'm going, and this is all stuff which Blue Crystal 4 is saying to me. Apart from this, I drew that for some reason. But there you go, Blue Crystal 4. That is also in London. So I am in a completely different place. One of the commands that we saw from earlier, which we didn't use, so we can go W or who, and we can look at all the other people who are logged into this machine, and we can spy on what they're doing. Most people are just running Bash and doing nothing. Or one person's using Python. There you go. You can feel like a hacker if you like. Anyway, that's SSH. Yeah, good points about the passwords. You liked my 4. Thanks. Thanks very much. Been working on that. I spent most of my PhD working on that. All good work. Okay, so that is how to actually move your so log in to a remote machine using SSH. It is confusing. If you're finding yourself confused, that's totally fine. It is not straightforward, and it's really easy to forget you're in another machine. It's really easy to be on the command line and go, where's my file? And you go, I can't find it. And then you forget that you're logged into a machine on the other side of the world. It's really easy. One thing that I do is I tend, and this is kind of advanced stuff, but I've coloured my prompts. I've made Blue Crystal 4 go red just to tell me that I'm in Blue Crystal 4. What have I done with? I haven't changed the other ones. But it's really easy to forget that you're not actually on your own machine. Okay, so that is being somewhere, and very finally, I realise I'm waffling. It's almost 5. Is moving stuff. Now, remember, any questions? Okay, it's always easier to move stuff from your local machine to your remote machine. This is a beginner's thing, is that people will go, like, if I go ls here we go. Let's go into meta. What have I got here? Disk usage. I've got a file here called disk usage, which has got some old stuff I did 2-3 years ago about how much data I'm using. Now, I can't copy that back to my own machine, because my own local machine does not have its IP address publicly available to the internet. It doesn't have. I'm not a network person, but I think it's port forwarding. However, Blue Crystal 4 does. Blue Crystal 4, as long as you're on the university VPN, does have its ports open so that you can get in. Okay, so I'm just going to very quickly demonstrate moving a file. What I'm going to do is I'm going to do a pwd, print my working directory. I'm going to take this path. I'm going to exit. Okay, I'm back on my normal machine, my local machine. Let's make a new directory called, and let's go into that. Oopsie, don't worry about my stuff. Let's clear that. Okay, and now ls, we've got nothing here. We're going to do an SCP to bring that file here. So we can go SCP, secure copy, and we will need, it looks more complicated, but it's really exactly the same as CP. Now I'm gonna have to do a history grep because I can't remember the full login to Blue Crystal. History into grep SSH. Now it will tell me that this is the most recent one that I did. So what we're going to do is we're going to go secure copy, and we're going to go, okay, and the first thing we say is, what do you want to copy? We want all of that as the identifier of who you are and what computer you're on. And then you need a colon. And then we need the path to where the file is in here. And we go, the file's called disk usage. And we can go, so that's what's moving, and the destination is here. So this dot is important. And I can go return, and it'll ask for my password. Oopsie, it's really difficult to do it when I think about it. Yay, it did it. There you go. Now I can go ls, and it will go, here you go, here's that file called disk usage, which is really useful. And then if I want to do it the other way round, it's exactly the same as with CP. Let's do it. So SCP. I'm just going to go tab. Oh, that's interesting. I didn't know it'd do that. No, let's do SCP and go disk usage. No, yes. Sorry, Zish is trying to be too helpful here. So I want to secure copy disk usage, and then I can put it all the way back. Let's take all of this. Let's call it something else so it doesn't overwrite it. Remember, if you send it and it's the same file, it will overwrite it. I can go SCP this file to the one on Blue Crystal, and I can go like that. Again, it'll ask for your password. And it should tell me it's done. So there you go. That is in an absolute whistle-stop tour, SSH and SCP, secure shell and secure copy. I have gone on for ages, but that is where I'm going to stop for today. I mean, if you followed everything we've done today, that is more than 95% of what you'll ever do on a command line, unless you're going to be some kind of genius. You're already a genius because you've already done this bit, so don't worry about the people who do other stuff. But there you go. You've learned how to make files, edit files, look at files, log into another area and look at files. But I think the most important thing to take from today is don't be intimidated. If you see a command, just try and work out what it's doing. Look at man pages, look on Google, and think of the structure where it goes from verb, adverb, object. Occasionally they're a bit more complex than that, but don't worry about that. And if you're starting to use redirects and you're starting to use pipes, then you've got it. That's it. That's really, that is the command line. And I hope it's a good introduction to coding and programming and the logic of programming, the words that are used in programming. Oh, VS Code. Marky or Marcy, apologies if I'm getting your name pronounced wrong. So VS Code is an IDE, an integrated development environment, or an integrated developer environment. It's something for helping you write code. We do a session on IDEs. I'm not sure if it's on this week. We do a session on PyCharm, which is designed for writing Python, and VS Code, which these days is used for writing pretty much everything, and it's an amazing piece of software. But if you're starting to use VS Code, then yeah, you're definitely on your way. But yeah, as I say, just, don't be frightened of the command line. Look up things. It's very difficult to break things. It is possible to lose data if you don't remember that it overwrites if you move things. But otherwise, you're going to gain so much more by just playing with the command line, moving around. Just try and do the things you do in the graphical user interface, but use the the command line interface as well. Like you can start absolutely every program you can think of from the command line, but I won't go into that today. Great, so there you go. If you've got any questions, do get in contact. Have a look at the rest of the courses that we have. We've got a couple of things, I think, this week for Data Week. There are plenty of other events on, seminars, talks about data and the future and ML and AI and all sorts of stuff. So have a look at the Jean Golding Institute's Data Week. So thanks again for your engagement, and I will see you around. Bye.